Hi everyone, we are now going to take up the chapter Coordinate Geometry for class 10th, and the reference again is going to be the Eduwiser's book, and the CBSE or the NCERT syllabus basically covers the following topics that we need to look at. They are concepts of coordinate geometry and graphs of linear equations. So in graphs of linear equations, you have already studied in the chapter on linear equations that you need to draw the Cartesian plane. So that is where the coordinate geometry comes. Then you also have the distance formula. So you have to learn about the distance formula. That's the distance between two given points in a plane. And the third important topic is the section formula. In the section formula, you have the internal division as well as the external division. But for NCERT, you are going to touch only the internal division part. But we will give you a just brief overview of what external division is about. And then we have the area of triangle. So in area of triangle, we will be covering portions related to finding the area of a triangle as well as conditions for collinearity. So let's start the chapter now. First things first, how do we represent a real number on a number line? You have a number line which is a horizontal line, you choose an origin, and then you put up points on that number line which actually are representative of the real numbers. So you have a straight horizontal line which extends both sides infinitely. You have an origin, and on both sides of the origin you have numbers demarcated on the line, and each of these numbers would represent a real number. So all rational and irrational numbers are represented as points on this number line. Any number that you take on this number line, it will be represented through a point. So the number √2 would be a point on that specific given number line, which is and the position of √2 would be relative to an origin that you choose. Origin is the point O that we have chosen in this number line. So for representing any rational or irrational number, that is a real number on a number line, you need to draw a horizontal line, you need to choose an origin, and you need to specifically mark out that point, that number as a point. So that's about the representation of a real number on a number line. How do we represent a point in a plane? We are here representing a point or a number on a line. How do we represent a point in a plane? A plane will have two dimensions, the horizontal and the vertical. So it will be encompassing a complete plane. So locating a point in a plane in absolute sense is not possible. Whenever you are going to specify the position of a point in a plane would be any flat surface. For example, the board that you see behind me, that's a plane. So you choose any point in this plane, you cannot absolutely define its location. You need to specify the location of a point in a plane relative to an origin and the choice of axis that you make about that origin. So for any point that you want to represent in a plane, you first have to choose a reference frame that should have two axes, the horizontal and the vertical axes, and the point of intersection, which is going to be called the origin. So the position of this point will always be relative to the origin that you have chosen. The fixed point that you have chosen is the origin. Now the Cartesian coordinate system. What is a Cartesian coordinate system? The position of any point P, as I said, it can be completely determined in a plane with reference to a rectangular coordinate system with rectangular axis or the axis x dash ox and y dash oy by means of an ordered pair x comma y. So when you specify the position of a point with reference to a rectangular coordinate system which has a horizontal and a vertical axis, it will be represented through an ordered pair x comma y, where x is the distance along the horizontal axis or the x axis, and y coordinate over the number y is representative of the distance of that point along the vertical axis or the y axis. So you have been given here that x is the length of perpendicular from the point P on the y axis with proper sign. With proper sign, we would come to that sign part in the next slide, but the x is the length of the perpendicular P on the y axis with proper sign, and it is equal to Pm, and y is equal to length of perpendicular P from the x axis with proper sign, which is equal to PL over here. So any point can be represented, any point P can be represented on a rectangular coordinate system by the ordered pair x comma y, where x is the distance, the perpendicular distance of that point from the y axis, and the point y, the the figure y is representative of the perpendicular p from the x axis with the proper sign, which is represented by PL in the given figure. So here you can see that the point P is represented by x comma y. What is L? L is the length of perpendicular. So L is actually the distance of that point, the perpendicular wherever it falls on the x axis. So if x is the length of perpendicular from the y axis, what will OL be? OL, since this whole thing, the OLPM quadrilateral, it would represent a rectangle. That's why we call it the rectangular coordinate system, because with any point, if you put the perpendiculars on both the axes, what you end up getting is a quadrilateral, which is a rectangle. That's why you call it the rectangular coordinate system. So PM is equal to OL. So OL, for OL, the ordered pair x comma y will be x comma 0. Why? Because the x coordinate will be same as PM, because in rectangle you have the opposite sides are equal. So if we have PM equal to OL, so for the point L, the x coordinate or the first part of the ordered pair will be x. The second part or the y part will be 0, because the length of perpendicular of the point L from the x axis would be 0. If you drop a perpendicular on the x axis from the point L, what will be the length of that perpendicular? It is already on the x axis, so the length of the perpendicular would be 0. Hence the y coordinate for L will be 0. Similarly, if you take for the point M, what will its coordinates be? It will be x comma y. What will x be? X is the length of perpendicular from that point on y axis. Now the point M is already on the y axis, right? So the x coordinate or the length of the perpendicular from the point M on the y axis will be 0. Hence you see that the x coordinate is given to be 0, and the y coordinate would be same as the y coordinate for the point P, which is equal to OM. So you have the point coordinate of M as 0 comma y. Now let's move to the quadrant and the signs that we just talked about. Any rectangular coordinate system, the axis x dash OX and y dash OY will divide the whole plane into 4 parts as shown here. So the first part, as you can see, is called the first quadrant, followed by the second, third and the fourth quadrant when you go about in the anti-clockwise direction. You just can't go in the clockwise direction. The coordinates count from anti-clockwise direction. So you have first quadrant, second, third and then the fourth ones. What is the sign for the points in each of these quadrants? In the first quadrant, for the ordered pair xy, the signs of both x and y would be positive. In the second quadrant, as you can see, the sign of x is negative while the sign of y is positive. In the third quadrant, both of them are negative, while in the fourth quadrant, the x coordinate is positive while the y coordinate is negative. So you take the length of that perpendicular. If the point is in the first quadrant, you take the length of the perpendicular and you prefix a plus sign. If it is in the second quadrant, you take the length of the perpendicular, and then if for the x coordinate you have to prefix a minus sign, and for the y axis, for the y coordinate you don't have to change the sign because it's already going to be positive. In the third quadrant, when you take the perpendiculars for both on the x axis and the y axis, you have to prefix them with a minus sign to get the correct coordinate for the point lying in the third quadrant. So this is how you have the points, any of the points in any of the 4 quadrants can be specified, and you also know about the signs that each of these points will have according as they are in the first, second, third or fourth quadrant.